As you move from the light elements to the heavy elements, you keep periodically coming across the same properties, which is why it's called the periodic table. The recurring properties are organized so that you can easily see similarities between elements. The periodic table is arranged in periods and groups, going from the light elements at the top to the heavy elements at the bottom. The rows going across from left to right are periods. Elements in the same period all share something in common. They have the same number of energy shells. Each new period row represents a new shell. Elements in the first period have one shell, and as we go down, the shells increase. Hydrogen is in the first period. It has one shell. Potassium is in the fourth period and has 4 energy shells, as do all the other elements in this period. The columns going down from top to bottom are the groups. Elements in the same group also have something in common. Elements in the same group have the same number of electrons in their outermost shell. The electrons in the outer shell are called valence electrons. This just means that these are the electrons available for reactions and bond formation. The number of electrons in the outer shell governs elements' reactivity, which is why elements in the same group have similar properties. The group number can tell you how many electrons are in this shell. For example, let's look at group 7. Fluorine, chlorine, iodine, bromine, and astatine. They all have 7 electrons in their outermost shell and all exhibit similar chemical characteristics. The properties show a gradual change going down the group as we go from period to period. So, if we look at group 7 again, we can see that they are each in a different period in the periodic table, telling us that each element in this group has its outer electrons on a different shell. So, chlorine is in group 7, period 3. Therefore, it has 3 energy levels with 7 electrons in its outermost shell.
We are going to look at Group 1 as an example of the pattern you can see in the periodic table. Group 1 contains the elements lithium, sodium, potassium, rubidium, cesium and francium. If you draw out their electronic structure, the first thing you notice is they all have 1 electron in their outer shell. The other thing to see is the number of shells they have is related to the row they're in the periodic table. For example, sodium has 3, so this therefore is their period. The elements in the group are all metals. They are all soft metals which can be easily cut. They get softer as you go down the group. Not that you would be wise to try and cut rubidium and cesium. All of the elements are stored in containers that either have paraffin or inert gases in. This is because of their reactivity. All the metals will react with air readily. They tarnish quickly in air, reacting quicker as you go down the group. Their reaction with water is violent and shows the same trend. Why is this? 2 reasons. Firstly, the outer electron they have is easily lost. Secondly, as the atom gets bigger, they find it increasingly easy to lose the electron. This is why cesium is the most reactive metal we know. The reason for this is the outer electron is a long way away from the nucleus and therefore is easily picked off. But also, the electrons in the other shells interfere and stop the nucleus holding on to the electron. This concept is known as shielding. This acts a bit like wrapping a magnet in paper and imagining that you're trying to use it to pick up nails. The more paper there is, the less nails the magnet will attract.